How many grams of petrol must you burn to raise the temperature of 750 milliliters of water from 15 degrees Celsius to 100 degrees Celsius? Okay, so first off, we got to figure out what energy we want. So the energy is going to be the energy needed to heat that water, right? So that's going to be MC delta T. So that's going to be 750 milliliters is 0.750 kilograms, right? Approximately, more or less. And then the specific heat of water is 4186, and that's joules per kilogram degrees Celsius. And then our temperature change is from 15 to 100. So 100 minus 15, I think, is 85 degrees Celsius. So let's figure this out first. 0.75 times 4186 times 85. That's a lot. That is 266,857.5 joules, right? So that's the energy we want. And then we are burning petrol, right? And the energy content of petrol is 45 megajoules per kilogram. So let's figure this out, right? So the energy is the mass times the specific energy, right? So therefore the mass is the energy you want divided by that specific energy, right? So that's going to be 266,857.5 divided by 45 times 10 to the 6. And this is joules per kilogram. And the mega, the times 10 to the 6 is because this is mega. Okay, so let's do this. I'm going to divide what's on my calculator by 45 E6, and I get that it's the mass, if it's 100% efficient, that is, if all this energy from burning this coal, or petrol, sorry, goes into heating up the water, then the mass you need is 0.00593016667. So that is, I'll just round it there, that's kilograms, or 5.93 grams. Either one of those, right? Although this specifically said how many grams. Okay, so that's at 100% efficiency, right? But let's suppose it's 65% efficient. That might be optimistic for like a little stove, right? Well, now the question is, how much energy do you need if it's 65? Well, you need more energy, right? Okay. So we're going to use this concept, right? This is going to be this is the output. Okay, and so we got to figure out the input, right? And so efficiency is output over input. Okay, so therefore the input energy is equal to the output divided by E. Okay, so the input energy is equal to, this is our output, right? Is equal to 266,857.5 divided by, and then the efficiency is 0.65. So let's find that number. Divide by 0.65, and this will give us a bigger number. Okay, so that is now the energy input, and this is the energy that's got to come from petrol, right, is 410,550 joules. Okay, so now we can figure out the mass of it that we'd have to burn if it's 65% efficient, right? The mass is going to be 410. I'm doing the same exact calculation here, only with this new number here. Divided by 45. And that's joules per kilogram. which will end up being kilograms, right? So that guy divided by 45 E6 is 0.009123 bar, and that's kilograms, or it's 9.12 grams. Ta-da! So now we've got, and by the way, if you just took this number here, the 5.93, and divide by 0.65, you'd get this too. Either way, right? So just remember, with efficiencies, if you're given the efficiency and you're trying to figure out the output and they give you the input, just multiply the input by the efficiency and you're done. And if they give you the efficiency and you're trying to figure out the input, then take that number and divide by the efficiency, because the input's got to be bigger, because some is wasted. At least that's the way I look at it. Obviously, you can just use the formula, right? That works too.